Welcome back everyone. This is the fifth video in the series of video lectures on the chapter motion for class 9. Earlier we have learned about distance and displacement, speed and velocity. Then we have learned about what is average speed and what is average velocity. We also have some idea about what is uniform motion. Okay. Now uniform motion, if you recall, uniform motion. If you recall uniform motion, what is uniform motion? Motion in which velocity of a moving object remains same. What should remain same? Velocity of the object. If the velocity of the moving object remains same, then we term that type of motion as uniform motion. Okay. Now the question is, in our day-to-day life, we encounter many examples of motion in which the velocity of the moving body keeps on changing. What is that type of motion then? If you recall, the motion in which the velocity keeps on changing with time, that kind of motion is termed as non-uniform motion. Okay, so non-uniform motion means the velocity of the object will change. Velocity changes. The velocity of the moving object changes. So this is a important characteristic of non-uniform motion. But is there a way in which we can measure what amount of change is taking place, what amount of change in velocity is taking place in what time? Or in a better way we can say, can we measure the rate at which this change in velocity is taking place? Listen carefully. Can we measure the rate at which this change in velocity is taking place? Is there some way of doing this? And the answer is yes. We define a new term. We will define a new term that is known as acceleration. We will define a new term that is known as acceleration. Let us denote it with small a. What does this acceleration characterize? Or what does it represent? It represents rate. But rate of what? Rate of what? Rate of change of some physical quantity. Or we can say the rate of change of velocity. So acceleration is that physical quantity that measures the rate of change of velocity. Okay? It will measure the rate of change of velocity. So it becomes pretty obvious that acceleration will come into the picture only when there is a change of velocity. In other words, in uniform motion, in uniform motion, since there is no change in velocity, acceleration will be 0. This is an important point. In uniform motion, since there is no change in velocity, already we know that uniform motion means change in velocity. Since there is no change in velocity, in case of uniform motion, what we can say, acceleration is 0. Acceleration is 0. So acceleration becomes a non-negative value, or acceleration of a body becomes non-zero when it is under non-uniform motion. So in non-uniform motion, acceleration is not equal to 0. We will discuss more upon this physical quantity, but let us first write the definition of this new quantity, acceleration. Okay? Let's see how we can write. Okay, so acceleration of a moving body in non-uniform motion is defined as change in velocity of the body. Change in velocity. You will divide this change in velocity with the time taken. So acceleration of a moving body is, you can see clearly here, change in velocity. Whatever change is happening in the velocity of a body divided by the time taken for that particular change. The physical quantity that you obtain by doing so is known as acceleration of the body. Okay? We will understand this with an illustration also. So now let us first check what will be the unit of acceleration. The SI unit of acceleration is meter per second square. Meter per second square. How we have obtained this? You can obtain this from here. I will leave this task up to you. You will find it out why it is meter per second square. Then let us try to write the formula for acceleration in symbolic form. Okay? Let's see what we have. Let A be the acceleration of a body. Let A be the acceleration of a body. Then this A is V minus U by T. Now what are V and U we will discuss. So we have A equal to V minus U by T. Now listen carefully. Suppose there is a body, say a car. Okay. There is a car here which is moving in this direction. And it has a velocity of U. When you start looking at the car, it has a velocity U. Now, after some time what happens? You observe that the velocity of the car has increased and it has become a new value, that is V. Listen carefully. When you start observing the car. You are the observer here. You see that the velocity of the car is u meter per second. Suppose this velocity is known as initial velocity. Initial velocity. And after some time, let the velocity of the car changes to a new value. Okay, and that value is known as final velocity. Final velocity. Listen carefully. This is the value of velocity of the car when you started observing it. After some time, okay, the velocity changes to v. And luckily, suppose you had a wristwatch and you were vigilant enough to measure the time. Suppose the car takes t seconds. I'm just assuming SI units. Suppose the car takes t seconds. How much seconds? T seconds to change its velocity from u to v. So this is the situation here. T is the time in which what is happening? The velocity of the car is changing from u to v. Okay? The velocity of the car is changing from u to v in t seconds. So these are the prerequisites. Now somebody is asking you, what is the acceleration of the car? What is the acceleration of the car? This is the question that has been asked to you, the observer. So in that case, what you have to do? First you have to find the change in velocity. First you will go for the change in velocity. Now change means what? Final minus initial. Change means final minus initial. Final velocity minus initial velocity. So we get v minus u. This is the change. The numerator here represents change in velocity. In what time it is taking place? Because rate means change in a certain time. In what time is it taking place? Okay, and the time is t, because you had a wristwatch to measure this time. So on substituting the values, we will have the acceleration of the car. If you put the requisite values here, whatever is required, v, u and t, you get your answer for acceleration. So whenever you need to find acceleration of a moving body, first you have to look if initial and final velocities are given. If they are given, then you find the change in velocity by subtracting them and divide it by the time taken for the change to take place. So these are the steps that you need to perform to obtain the acceleration of a car. So this was about acceleration, and one more important point about acceleration is this. One more point we can discuss. About acceleration is a vector quantity. Vector quantity. Okay. Vector quantity means it requires magnitude, it has a direction, plus it follows some special laws of addition. Special laws of addition. Okay. Now acceleration is a vector quantity, and one more thing. Acceleration is said to be positive. Okay. Okay, acceleration is said to be positive if it is in the direction of velocity. If it is in the direction of velocity. And when will acceleration be negative? When it is opposite to direction of velocity. Okay. Acceleration is said to be positive if it is in the direction of velocity, and acceleration is said to be negative if it is in opposite direction of velocity. And when is acceleration 0? And when is acceleration 0? In uniform motion. Clear? I hope it is clear to you. Okay. So let us solve one numerical based on finding acceleration. This example is from your NCERT textbook, and I will write the question first. Okay, before solving the numerical, we need to learn two more points about accelerated motion. So accelerated motion means non-uniform motion basically. Now this accelerated motion can be uniformly accelerated motion as well as non-uniformly accelerated motion. In nature we find both of them in abundance. Okay. Uniformly accelerated motion. See the words. Uniformly accelerated. Uniformly accelerated. That means whatever acceleration is happening uniformly. Now what does it mean? Whatever acceleration is happening uniformly. Okay. Now the meaning of this is that uniformly accelerated motion means equal change in velocity in equal intervals of time. Uniformly accelerated motion means velocity is changing, but the rate of change of that velocity is always fixed. That means equal changes in velocity is happening, but in equal interval of time. In equal interval of time, change in velocity is always same. That kind of motion is known as uniformly accelerated motion. So what will be non-uniformly accelerated motion? Unequal changes in velocities in equal intervals of time. That you can say. You can say unequal change in velocity in equal intervals of time or equal time intervals. Okay. Now it is very interesting to find examples of these cases. It is very interesting if you can find the examples of these cases. Examples of uniformly accelerated motion, examples of non-uniformly accelerated motion. Okay. So I will give you a job so that you can do this at your home. What you will do, you will try to write 3 examples of both cases. Try to write 3 examples of uniformly accelerated motion and non-uniformly accelerated motion from your own observations. Okay. From your own daily observations. Try to write 3 examples of both cases. Okay, so that you can understand acceleration properly, let us try to solve this numerical. Okay, it's a simple illustration. It's a very simple numerical. So the question goes like this. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find acceleration of the bus. So the moving object here is a bus. And what is happening? The bus is decreasing its speed from 80 km per hour to 60 km per hour. So, and this change is taking place in 5 seconds. And you are asked to find acceleration of the bus. First thing, whether the motion here is uniform or non-uniform. Okay. See, the velocity of the moving object is changing. So that means it's non-uniform motion. Now since it's non-uniform motion, we can find its acceleration. Okay. So acceleration, you have to recall the formula for acceleration. What was the formula for acceleration? If you recall the formula for acceleration, A is equal to V minus U by T. What is A here? A is acceleration. What is this V? You may be thinking that it's velocity. It's definitely velocity. But what velocity? Initial or final? You have to think about that. It's final velocity. What is this U? U represents initial velocity. Okay. What does this T represent? The time taken for the velocity of the moving object to change from U to V. So these are the various parameters that are there in this particular formula. So now you have to see the question and see what are the parameters that are given here, or what values are given. So if you compare the equation, you can see first 80 km per hour. You have to think whether this is U or V. For that you have to read the question. You see that the bus decreases its speed. Decreases means its value of speed, that means it becomes less. So initially its velocity was 80 km per hour. What did I say? Initially. That means this is your initial velocity. So you will write U is equal to 80 km per hour. Now to convert this kilometer per hour to meter per second, I hope you have learned this. We multiply 5 by 18. So you need to carry out this calculation 5 into 400 and this by 18 meter per second. This is your first step. Now, since we have found out U, now the question says that the bus changes velocity from 80 km per hour to 60 km per hour. That means the final velocity is 60 km per hour. So what we do, in the next step we write V is equal to 60 km per hour. Convert this into meter per second. 60 into 5 by 18. So whatever will be the 300 by 18 meter per second. We will not divide now, we can divide it also, it's your choice. Done. Next, what is this? This is obviously the time is 5 seconds, that means the change is happening in 5 seconds. Next we will find acceleration. So what we will do, let me clear the board first. So T is equal to 5 seconds. Therefore remaining acceleration is V minus U by T. Acceleration is V minus U by T. Put the necessary values, you get your result. Okay, if you put the values, you can see the values here. Okay, so your final velocity is 300 by 18. 300 by 18. Initial velocity is 400 by 18 divided by 5. Since we have converted everything into SI unit, that means acceleration will have unit of meter per second square. Remaining is calculation. Remaining part is calculation. So you can see, if you calculate this, meter per second square, meter per second square. So this gives us a result of minus 10 by 9 meter per second square. So this is your answer for this particular numerical. You see the acceleration here is in negative. See, acceleration is negative here. That means acceleration velocity of the body has dropped. It has decreased, which is already given in the question. Okay. So you can, as a homework, you can try example 8.4 from your textbook. Okay. You can try example 8.4. Try this at home. Example number 8.4. You will find this in page number 103. Okay. So this will clarify your concepts a little bit more. Thank you for watching this video. In the next video, we will discuss graphical representation of motion. Okay. Thank you.